All right, vector projection of A onto B is going to be dot product of A and B over dot product of B with itself as a scalar multiple of vector B. So that's going to be 0, 1, negative 2, dot product with negative 1, 0, 3, negative 1, 0, 3, dot product with itself in the direction of vector B. So that's going to be 0 plus 0 minus 6 over 1 plus 0 plus 9, right, in the direction of vector B. So as a scalar multiple of B, this is going to be negative 6 over 10B, which is negative 3 over 5B. So if we're going to leave it as a scalar multiple, we would leave our answer in this form. But you should probably give me the component form. So this is negative 3 over 5 times negative 1, 0, 3. So your final answer should be 3 over 5, 0, negative 9 over 5.
It's better to leave it in decimals or
Just give me fractions, usually. Yeah. I mean, if they're exact values, it doesn't matter. And then for vector projection of B onto A, this is dot product of B and A over dot product of A with itself in the direction of A. But keep in mind that you already calculated dot product of A and B, because that's the same as dot product of B with A, okay, which is this negative 6. So it's negative 6 over dot product of A with itself is going to be 0 plus 1 plus 4 in the direction of vector A. So as a scalar multiple of the vector A, it's going to be negative 6 over 5. But again, in component form, we should multiply this into the coordinates or the components. And we end up getting our final answer, 0, negative 6 over 5, 12 over 5. For the vector projection of A onto K, remember K is the unit vector on the positive z-axis. So its components are 0, 0, 1. Remember? Yeah. I is 1, 0, 0, J is 0, 1, 0, K is 0, 0, 1. So vector projection of A onto K, that's going to be dot product of A with K over dot product of K with itself in the direction of vector K. But anytime you have, if you have any vector multiplied with one of the unit vectors, the only thing that's going to be left is that component, right? Because this has the component 0, 0, 1. So from the vector A, the only component that's going to be left is the z component. Okay. So if you want to write it out, you have 0, 1, negative 2, dot product with 0, 0, 1, and then 0, 0, 1, dot product with itself, all in the direction of K. So that's going to be 0 plus 0 minus 2. So you are left with, it's just the z component of the vector A. Questions? So let's see, if we just wanted to, as a second example, if I asked you for vector projection of A onto J, what would your answer be in one step? The vector projection of A onto J. 0, 1, 0, because that would be 1 is our y component of the vector A. Okay, that's it. And what if I asked you for vector projection of A onto I? What would it be? It's going to be the 0 vector. It's the x component of vector A. Okay, the 0 vector. Alrighty, last but not least. When you have vector projection of I onto A, that's going to be dot product of I with A over dot product of A with itself in the direction of A. But what's the dot product of A with I going to equal? 0. So this is 0 over, and then, well, it's the magnitude of vector A squared, which is going to be 5. But that's just going to be the 0 vector. Okay. Any questions? Sarah?
When it asks for the vector projection, do you always have to show the coordinates, or can you just put like 6 over 5 over A?
Oh, for the final answer, give me the components, yeah. And that's it.